Good morning, students. In this video, we will discuss another example how to convert an ER diagram to a relation model. So what I have taken is that if you see that we have constructed this ER diagram in our earlier videos. So what is the requirements they have given? There are some students studies in some department. So n number of students can study for a department. So that's why it is n number of students studies in a single department, and all the students should belongs to some department, so that's why it is a total participation. And even we have taken an example that there are a department which does not have any students, so that's why it is a weak or partial participation in the department side. And we have a attribute student ID and student name belongs to student entity, and department ID and department name belongs to department, and SID is acting as a primary key attribute here, and department ID is acting as a key attribute for the department table. Now how can we have a relational model, or how can we convert this ER diagram to a relational model? So as we said earlier, we will have two tables. One is the student table and another one is the department table. Student table will have student ID and student name. Department table will have department ID and department name. What are the attributes are there? Just I have represented. The name of the entity student will act as a name of the relational model, means the table. So you have a, here it is acting as a key attribute, so we will call it as a primary key here, because in ER diagram it is acting as a key attribute, so it will be converted as a primary key in the student table, and here it will act as a primary key. It is good, we have, but we have any relationship between them? No, they are separate tables till now, because a student table having the attributes, department table having attributes, but we want to have a relationship between these student table and department table. How can we have a relationship? The primary key of the one table, if it is acting as a foreign key, then we can have a operation, means join operation, to retrieve the information from the two tables. Because if you are maintaining the information in separate tables, when we want to retrieve the information, let's take the student ID 1, in which department he is studying. If I want to have information, then I need to join these two tables. If I want to join, I need to have a common attribute. If I does not have any common attribute, what I have to do? I have to apply the Cartesian product. All these things you will study in the relational algebra, don't worry. So what I want to say is that simply understand that one primary key of one table, if it is acting as a foreign key, then it is very easy to retrieve the information from more than one table. So the first case is that I will make the student ID as the foreign key here. What is this way? If I do like this, student number 1 is studying in, his name is A, B, C, like this. If it is there is a department ID D1, D2, it is there, and it is CSC and it is mechanical. Okay, and there is a new department called, some department will take it. Let's take the EEE. Some department, just for taking an example I am taking. There is a department which does not have any students. It's a new department. Okay. Now department 1 means A and B are studying in CSC. Let's take that. C is studying in the mechanical department. Then what I have to have in the department table, DBID, in the student 1 and 2 is studying. Is it clear? And the mechanical ID 3 is studying in the mechanical, and in EEE there is no students right now. Okay, at this instant there are no students. Now what is the problem with this one? Obviously if I am making it as a prime foreign key here, obviously 2 students are studying in CSC department. That is what I have entered. But what is the problem here? It is becoming as a multi-valued attribute. That is not allowed in any tables. Is it clear? So we cannot go like this. What is the another way? Make the primary key of the department table as a foreign key in this one. What will happen? We will see. Now A and B are studying in which department? CSC department. So in D1 they are studying. Okay. In 3, name C is studying in mechanical department D2. So this is a good entry. Is it clear? Maybe it is a duplicate. We cannot do it. We cannot eliminate this duplicate, because A and B are studying in department 1. What is the problem? So we should, if you have a relationship or ER diagram like this, the better way of designing is that keep the department ID as a foreign key in the student table. If you are making it another way, it is creating the problem. So this is the better design. Is it clear? See, in the previous case also you can go for the design, but the better design is this way. Now I want to discuss another point. If you have an attribute called since, means from which date he is studying, to which side you have to shift. Are you able to understand? There is an attribute called since to the studies relationship. If you don't want to shift anywhere, you will have three tables. One table for student, one table for studies, one table for the department. You will have three tables. It is also a good design, but whether it is an efficient design? No, it is not an efficient design. When it will become an efficient design, if I can reduce the number of tables, then it is good. When I can reduce the number of tables, either I can shift this since to this student, or if I shift to this side, it is better, because then obviously with the two tables I can manage the situation. So where I have to shift? Let's take that we are shifting to this side. Okay, if I am shifting to this side, then what will happen? Two students are studying in CSE department. Then student number 1, I have to enter the details, comma, student 2, I need to enter the details. Then it is becoming as a multi-valued attribute. Are you able to understand? Because A and B are studying in CSE department. Then if I write in department 1, A and B are studying, and from which date they are studying, if I enter, it will become as a multi-valued attribute. Okay, so the better way is that keep the since, okay, keep the since here. In the, I want to say that you keep the since attribute in the student table. So student number 1, whose name is A, he is studying in department D1 since 1/1/2020, and this person is studying 1/1/2019, because let's say that he is studying second year, he is studying in the, means he is studying second year, he is studying first year. So they are juniors and seniors. Just I want to say. Is it clear? So if you have a attribute called since, better you shift towards the student. Is it clear? How we understood that? If you have a one, as the cardinality here it is n, so you shift to this side. That is where you can remember. Or if you don't want to remember like this, you can go what are the ways I have discussed, and you have to analyze what is happening. If you are moving the since attribute to the department, what is happening? So you have to analyze, then you shift it. So I can say that with the two tables I can manage in a better way, and shifting this attribute to the student entity. Okay, I hope you have understood how I have converted an ER diagram which is having one-to-many relation to an equivalent relational model. Okay, I hope you have understood. In the next video, we will discuss the another case where you have a ER diagram and the relationship between the two entities is many to many. If it is like that, what we have to see, we'll discuss now. Okay, thank you so much.